Okay. So we are solving the equation fx. Here we're looking for a root of this equation, correct to 6 decimal places, and we are going to use the Newton method. In order to use Newton method, we need to start with an initial guess. In this case, let us pick 1. X1 is 1. And we need to find f prime of x, right? And f prime will be the derivative of cosine of x minus x here, which give us
negative sine minus 1.
very good, negative sine x minus 1. Therefore, we have the derivative of this already, right? Very good. So the step, let us call it step 1, right? Or call it steps 2. Step 1 is the initial guess. Okay. Then we need to compute x2. And from the Newton method, we know that x2 will be x1 minus f of x1 divided by f prime of x1, right? So x1, what is x1 here? Very good. Minus f of x1, which will be cosine of 1 minus 1 here, very good, divided by, very good, thank you, Matthew. Then please use your calculator and compute this. Remember, when we compute trig function, change to trig change the degree to radians. Yeah. Thank you. And tell me what you get for x2. Diana, do you have a calculator? So do you get the same result here? Good job. Then we have x2, right? Remember, do not round it until, do not round it. Keep it as much as you can because we want to compute the correct up to 6 decimal places, right? Keep it as much as we can. So same story. Step 2, we need to compute x3, which will be x2 minus f x2 divided by f prime x2. And we know x2 from this 0.75, 0.3, 6, 3, 8, 6, 7, 8 minus f of this number. Or let me substitute that into the formula. Cosine of 0.75, 0.3638678 minus this number 0.75, and use your calculator and compute the x3, please. Divided by and tell me what you get. 0.739 and perfect 9, right? And 1 at the end. Very good. Now, let us try to find the difference between x2 and x3. Yes.
How did you get 0.75 for x2? I got 1.45.
You mean here? Type 1 minus cosine, but you compute it in radian. Double check it. Did you use it in radian? Okay. And I'm using a laptop, so I can simply type it in here. It shows me the result. I believe that you get the same one if you use your calculator. You get the same result? Okay, very good. Then having x2, we can compute x3, right? Remember, computing it in radian, very important. Then we have x3, very good. Now find the difference between x2 and x3, please. And tell me what the difference is. Hold on a second. I'm sorry, it's freezing. Sorry about this technical issue. Interesting. Can you all wait me a second? I would like to reset, refresh. Okay, now x3 minus x2. Let us take the absolute value of this. And tell me again, Carson.
0.01125. 0.77.
Thank you very much. See, the difference between x2 and x3 is about 1.12 10 to the minus 2. So it's not close to 6 decimal places, right? So therefore, we need to do it, continue doing it until the difference between the two two numbers are small enough, smaller than 10 to the minus 6, okay? Now, let us do in the step 3. x4, this is step 3, this is step 4, give us x4, will be x3, and you know how to do it, right? Please go home and double check it. For now, I'm giving the result of this. x4 give us close to 0.73908 513. Oh, sorry. Sorry, people on Zoom. I forgot sharing the screen. Okay, here we go. Now, this is x4. Very good. Then we do a similar things to find x5. It will be x4 minus fx4 divided by f prime x4, which gives us 0.73908,513. Okay? Now look at this. The x4 is 0.73908,513. This one is also close to this, right? Therefore, the difference between these is smaller than 10 to the minus 7, somehow like that. We observe when you compute the difference, okay? So we see that the error between the difference between x4 and x5 agree to 6 decimal places. we conclude that the root of the equation correct to 6 decimal places is the number 0.739085. This is a solution of this equation. So let us try to draw a graph of the function. If this is y, this is x, right? Then here is 0. This is pi over 2. This is pi, 3 pi over 2. And here is 2 pi. Negative pi over 2. Negative pi. Negative 3 pi over 2. Negative 2 pi. If this is 1, then the cosine function cosine at 0 give us 1, right? Cosine at pi over 2 would be 0. Cosine of pi would be negative 1. At 3 pi over 2, it would be 0. Go back here. And at 2 pi, it would be like this. And it is a periodic function. So with a period 2 pi, so it would be like this, right? This is the cosine x. And pi over 2 is about 1.5 something. Therefore, the graph y is equal to x should be like this. So the solution of cosine x and x will be the intersection of these two. And it cut here. This is the solution, right? Go home, double check on an online grapher, you see it. Okay, but now Newton method give us a similar one, close enough. Then basically that is the Newton method. So do you have any question about this? We're good, right? Just apply the formula, give an initial gas and compute. Okay. For people on Zoom, do you have any question? Very good. Okay, let me see. Thank you. So now let us move on to a new topic, section 4.9. About antiderivative. So we know how to compute the derivative, right? And now we want to know how to do the inverse process, how to find the antiderivative. Let me stop recording and start a new session.